Welcome. We're on page 2 of our Chapter 7 exam practice, and this is number 9. A confidence interval for a population mean is given by the following. We're going to put that information here on our number line and then write the interval in its alternative form. So let's start here with our lower limit is 62. Our upper limit is 78. All right, and we'd like to find the point estimate, the sample mean, and the margin of error for the confidence interval. So let me start with finding X bar, the point estimate. So the point estimate will be in the center of that confidence interval. So if we take the lower limit and the upper limit, add those and divide by 2, we'll be averaging those values, and that will give us that center value. So we'll take 62 plus 78. And we'll take that sum and divide it by 2. So 62 plus 78 gives me 140, and then divide that by 2, and that is 70. All right, so now I know the center of the confidence interval, the sample mean is 70. And then to find the margin of error in the confidence interval, we could just look at this difference. So 70 to 78 is a difference of 8. And this difference, 62 to 70, is a difference of 8. So margin of error is 8. You could also find it using the formula. So margin of error, if you take the upper limit and subtract the lower limit, the length of the confidence interval, divide that by 2, that gives you your margin of error. So we can take 78 minus 62, divide that by 2. So in that numerator, the 78 minus 62 is 16. That's the length of the interval, divide by 2. And that's another way to get 8. So margin of error is 8. All right, so our second form of the interval. So we could say that mu, the population mean, we estimate to be the point estimate. So in this case, it'll be the sample mean, plus or minus the margin of error. So in our case, we're estimating mu to be 70 plus or minus, sorry, that looks a little weird. Let me try that one more time. So 70 plus or minus 8 would be the equivalent. All right, number 10. Based on a sample of 400 students, administrators estimate that the proportion of all students at their college who have a car is 35%, accurate to within 3%. And we're going to write that information as our confidence interval here. So just to review symbols, the point estimate for a proportion is our p hat, our sample proportion, and then plus or minus our margin of error. All right, so they tell us that their estimate is 35%. So that 35% was p hat, their sample proportion. And we could write this in decimal or percent. I'm just going to go ahead and stay in percent. So 35% plus or minus. And then the key to looking for your margin of error, if you see within, that's a good indication there. That's your margin of error. So 35% plus or minus 3%. Okay, so let's write that in the form with the lower limit and upper limits. All right, so for your lower limit, if we take our point estimate, 35%, subtract our margin of error, that will be 32%. And then for our upper limit, we take our point estimate, 35%, and we add the margin of error. That will bring me to 38%. All right, so based on a sample of 400 students, we could have written this equivalently as administrators estimate that between So between indicates we want our lower and upper limit. So between 32% and 38% of all students at their college have a car. Okay, I want to write that confidence interval in the form lower limit, upper limit, just for practice here. So if we go with percents again, oops, sorry, the lower limit, 32%, and then to say between, we'd have the less than sign, and then we're estimating P, the proportion of the population that have a car, less than sign, and 38%. So just reminding you that when we're estimating a population proportion, that's P, versus up top when we were estimating a population mean, that parameter is mu. All right, let's go to number 11. You do a study on hypnotherapy to determine how effective it is at increasing hours of sleep that subjects get each night. And you record hours of sleep for 7 subjects. And we'd like to find the best point estimates of the parameters. So we're going to look for the best point estimate for the population mean and the best point estimate for the population standard deviation. All right, so the idea here is we don't know the population mean and we don't know the population standard deviation because we just have a sample of subjects. So if you'd like to estimate the population mean, the best point estimate is the sample mean. And if you want to estimate a population proportion, the best point estimate would be the sample proportion. So we use samples, and those would be called statistics. So we use these sample statistics to estimate these population proportions. All right, so if you put that data into L1, we can just use one of our stats to get our values. So if you enter that data in L1, and then you can just do one bar stats. So if you want to pause for a moment and get that data in, I've done that already. So data in L1, and then we'll do stat, calculate, first choice, one bar stats. So that's on the home screen. And if your data is in L1, you can just hit enter. And the directions are around to 2 places. So X bar would be 8.07. I'm not writing a sentence here, but I'm still just going to put units in. So I'm going to estimate that the population mean amount of sleep subjects get is 8.07 hours and an estimate for sigma. So be careful here that that sigma on the screen is not relevant. This data is not a population set of data. So you're looking at S. So S is sample standard deviation round to 2 places, and that will be 0.07 hours. All right, number 12. A textbook publisher surveyed a random sample of 96 college students, and in that sample, 28 students preferred printed textbooks and 68 preferred electronic textbooks. Let's find P hat, so that's the sample proportion, and they want the sample proportion who preferred printed textbooks. All right, so P hat, the sample proportion, we take X, the number of successes in the sample, we divide that by the sample size. All right, so in this case, if they're talking about students that prefer printed, 28 would be our X, that's the successes in the sample, and then our sample size was 96. So 28, oops, sorry about that, 88, not 88, 28 divided by 96. All right, and we're going to write that as a percentage rounded to the nearest tenth of a percent. So we'll take 28, divide by 96. And just to review tenth of a percent, I'm going to just write down some digits here after the decimal. Let's do ... there. So in order to round it to a tenth of a percent, first we would change it to a percent. So that decimal point would move 2 places to the right. So we would have 29 point. And then that third digit there is a 1/10 of a percent. So it's in the tenths position after we move the decimal point, and it's a 1, but it has a 6 next to it, so 1 would round to 2. So my estimate is 29.2% of students. All right, one more on this page, number 13. Okay, so we have a random sample of 12 drivers that used an average of 754.2 gallons of gasoline per year with a sample standard deviation of 33.5 gallons. We're going to find the 90% confidence interval estimate of the mean for all drivers. I'm just going to highlight there. The parameter we're estimating is the population mean mu. And let's figure out what confidence interval we use on our calculator for this particular problem to find that estimate. All right, so the symbols here, so it was a random sample of 12 drivers. So there's our sample size, lowercase n. And then the average, the mean for those 12 drivers, 754.2. So that's X bar, the sample mean. And then we always have to be careful with standard deviation to make sure we get the symbol here correct. So this is the sample standard deviation. So that is S. All right. So the temptation when we see standard deviation is to write sigma because we did that all throughout chapter 6. But now here in chapter 7, we just have to really pay attention, and it's sample, not population standard deviation. All right, so they do say assume the distribution of gallons used is normally distributed. So that last statement is required because the sample size 12 is considered small for us, so under 30. So that last part just allows us to move forward and pick our correct distribution. So the sample standard deviation is known, but the population standard deviation, sigma, is not given to us. It is unknown to us. So when that happens, we need to pick our t interval. So the confidence interval will be based on the t distribution. So when the population standard deviation is unknown, and you are estimating mu, the population mean, we either pick z or t. And if you don't know sigma, then it's a t. All right, so let's check it out here. So we'll hit stat and tests, t interval. And the input here, we have the statistics. They didn't give us the actual data. So pick statistics and then enter our X bar, 754.2. There's our sample mean, and S, 33.5, sample standard deviation. N, sample size 12. Confidence level 90%, so 0.9. You can put the 0 if you'd like, 0.9, 0.90, and calculate. All right, and it's saying to round to 1 decimal place. So my lower limit there, 736.8. And then we're writing our confidence intervals in this form. So the parameter we're estimating is mu, the population mean, and then the upper limit, 771.6. All right, so I don't have a sentence here written, but I'm just going to speak it. So we would say based on the sample of 12 drivers, we are 90% confident that the true mean for all drivers is somewhere between 736.8 gallons and 771.6 gallons. All right, and that ends page 2.